Welcome to Spring LIB.
So it's critical in an electrolysis problem to find the number of moles of electrons that are being transferred in the reaction. So we can do that by looking at the change in oxidation state from aluminum in its oxide to its solid form. So we know that in the solid form it's going to be 0. The oxidation state of aluminum in aluminum oxide, if we know that oxygen from our oxidation state rules is always -2, and we assign aluminum to be x. That gives us the equation 2x minus 6 equals 0, 0 being the fact that this is a neutral species. That means that x, or the oxidation state of aluminum, is +3, and therefore there are 3 electrons needed to reduce the aluminum to its pure form. So now that information is going to be really helpful. We can take the time, we're given time and current. We can use our equation current equals charge over time to give us the charge. We can use Faraday's constant to determine how many moles of electrons are needed to produce that charge. We can use the mole ratio, which is where this 3 comes in, to determine the moles of aluminum that could be reduced in given that amount of electrons. And then we can use the molar mass of aluminum to determine what that mass is. So what we need to do is get the time in seconds, which is key because the amps that are given is coulombs per second. So we just need to get time in seconds, so that's 6,400 seconds, and then multiply that by 1 times 10 to the 6 amps, which is 1 times 10 to the 6 coulombs per second. So that will cancel seconds out, and you will be left with the charge. So we take that charge, we use Faraday's constant to determine how many moles of electrons were transferred. And then we can say, okay, so if those are number of moles of electrons, and there's 3 moles of electrons for every 1 mole of aluminum, that will tell us how many moles of aluminum were reduced with that number of electrons. And then we can use the molar mass to get the mass of aluminum, which is going to be 597 kilograms.